All right, let's talk about the magic box on your desk, or, that little slab of glass in your pocket. Ever really wonder what's going on inside? Like, deep down? Well, today, we're pulling back the curtain. We're going to get into the fundamental principles that power literally every single digital device you use. This is the real insider's guide to how a computer actually works. So let's just jump right in with a question. Think about your smartphone for a second. All its apps, games, everything. Now, picture one of those massive, room-sized supercomputers, the ones crunching insane scientific models. What could they possibly have in common? It seems like nothing, right? Well, the answer is actually surprisingly simple, and it's the key to, well, everything we're about to talk about.
Okay, so here's how we're going to break it all down. First, we'll look at the master blueprint that pretty much every computer follows. Then we'll peek inside the engine room to see the core parts. After that, we'll meet the conductor of the whole orchestra. That's the operating system. We'll see how it came to be, and finally, dig into how it manages to juggle everything at once.
All right, first up, the computer's master blueprint. We're talking about the absolute fundamental design here. Think of it as the DNA that's shared by just about every computer built since the 1940s.
And here it is. This is the answer to that big question we started with. It's called the von Neumann architecture. This design, which was dreamed up way back in 1946, is the foundational concept that basically makes your phone and a supercomputer distant cousins. It's the whole reason a single machine can be a universal computer. Why you don't need one box for typing and a totally separate one for watching movies. This one brilliant design can be programmed to solve almost any problem. Now, the ideas behind this they were totally revolutionary. The biggest one? That the program, the instructions and the data it's supposed to work on are stored together in the very same memory. That was huge. And everything in that memory gets a unique address, kind of like houses on a street, so the computer always knows where to find stuff. Instructions are read one after another, in order, but, and this is crucial, special jump commands let it skip around. That's what makes software so dynamic and, well, smart. And the foundation for all of it? Every single thing is just ones and zeros, binary. So, okay, we've got the blueprint. But that's just a design, right? An idea on paper. How does it actually work? How does it come to life? For that, we've got to go inside the engine room. Let's use an analogy here. The CPU, the central processing unit, that's the brain. It's the part that does all the actual thinking and the heavy lifting, all the calculations. But even a brain needs a desk to work at, right? A workspace. And that's RAM, or random access memory. The RAM is like the computer's desktop, holding all the data and program instructions the CPU needs, like right now. And